Let me start with the introduction of the VAT company. As probably many of you have never heard of VAT, we're a typical B2B company, so we're hardly known outside of the high vacuum sector. But if you have a smartphone with you, I'm quite sure that the semiconductor chips that are in your smartphone have at least seen one of our valves while they have been produced. We're located in Switzerland in the beautiful Rhine Valley, around 2,500 employees, and we're having a very dominant market share in vacuum valves, especially in the semiconductor industry. Around 70% of valves for lithography, etching, coating, and so on. This comes from us, so we have the broadest technology portfolio of valves. We further invest 40 million per year in development and also customize a lot of valves. So we have a big engineering workforce that is doing valves for specific applications or for very specific customer needs. And in the business unit Advanced Industrials, we're taking care of everything that is not semiconductor. So research, scientific instruments, and so on. And in the sector industry, Hyperloop is one of the most interesting applications for us due to the huge growth potential that we see in there over the next decade. And therefore, we're also making product development for Hyperloop. I brought here some examples of what we have made in the past. So the top valve here at the top, this is the ITER absolute valve. This is for nuclear fusion. So this is for the best vacuum in the world. There is less gas in such a system than you have on the surface of the moon. That's of course pretty far from what you need for Hyperloop. And the examples here at the bottom, that one here, that is a bit closer to what we need for Hyperloop. So this is the biggest valve that we've made. It's 2 meters in diameter. And such valves are used for space simulations usually. Another example, here the monowatt. I brought this example because this is especially interesting for Hyperloop. It's a patent from the 80s from VAT. And we have used this, as you see the example here, for very wide valves for display coating, but it can also be adapted for, or it's also used for smaller valves with a round shape. And the big advantage, I explained you here, because if you have a standard valve, you typically have a two-direction actuation. You move the gate into the seat, and then you have another actuation towards the flange to close vacuum tight. First we call this optically closed and then vacuum tight, and you need a relatively big gap then in the track. And from our exchange with Hyperloop corporations, this means that you have a movable part in the track, which of course adds complexity. That's why we've chosen the monowatt valve design. And there we only have one actuation up and down, and the valve seat. So the seat is what is staying in the valve where the gate is pressed against to close the valve. So this seat can be integrated in the track. So this means, of course, then reduced complexity, cost reduction, and other benefits like scalable and compact. I also have here a little movie just to illustrate the valve functioning. Not moving. Okay, then I explain just with the example of the top-based track myself. So we have the gate here below the track. So we have a top-based track, and we move the gate upwards into the seat to close. The gate shape at the top of the gate, this has to be adapted to, of course, the track design. And the seat itself, this is part of the tube. So this is in the tube and has then the counterpart for the gate, where the gate moves in. To prove the principle, we've also built a functional sample that you can see here on the pictures, around 1 meter by 0.6 meter. The gate moves up and down, and in this specific setup that we've built here, we're using the force under vacuum. So when we soak vacuum, then actually this small tiny gap here between the plate and the counter gate, this is then reduced because the vacuum force presses then the gate against the counter gate. And yeah, this principle can be scaled up to 4 meters. And yeah, we're looking forward to first the possibility to install the valve. And yeah, for potential partners, you're of course welcome to come to Switzerland, have a look at the functional sample and discuss potential cooperation with us. Thank you.